Hey guys, this is Mr. Bouchard, and I'm teaching the astronomy unit now. This is chapter 8 in the UPCO book. So what we're looking at here, this is a picture of the universe, but this is zoomed way in, so taken from a space telescope. This isn't what you would see on the Earth's surface, because you notice it's not just stars, you're actually looking at galaxies. Right, which are clusters of stars. So we're going to talk about that in a little bit. You can see all the different colors too. There are different colors indicating different temperature stars. All right, we'll be talking about that a little bit, but next year when you take Earth Science, you'll go into that in greater detail. But this is the universe as zoomed in quite a bit. This is taken from the Hubble Space Telescope, all right, called the Hubble Deep Field. So you can look up those images online. All right, so chapter 8 is astronomy. It's universe, galaxy, stars, solar system are what we're going to focus on today. So let's look at those terms and understand what they are. So galaxies are basically collections of billions of stars, gas, dust held together by gravity. So gravity kind of holds everything together. Everything in the universe is moving. Okay, and we'll talk about the formation of that in a moment. Each galaxy averages about 100 billion stars, so that's a huge number. This again makes you feel very small because our closest star is the sun. Okay, and that just shows you how big the universe truly is. There's over 100 billion galaxies in the universe. Okay, so again, enormous universe basically. All right, so what types of galaxies are there? These are just a few different ones. There's some other ones also, but these are the just minor ones. So spiral galaxy, elliptical galaxy, and an irregular galaxy. All right, so you can see spirals have the arms that come out. Elliptical have more of like an oval shape, whereas an irregular is just scattered gas and dust. Okay, our galaxy is named the Milky Way, so the candy bar is named after it. It has 200 billion stars and it's spiral shaped. Our solar system is actually on the Orion Arm. They're actually showing it in the wrong spot in this picture. It should be actually about 2/3 of the way out on the Orion Arm. So we are nowhere near the center of our galaxy. All right, so again, in the past, they thought everything was around the Earth. Well, they were incorrect about that. All right, our galaxy, just so you realize, is 9.25 times 10 to the 17 kilometers. Here it is written out. So that's 925 quadrillion kilometers. That's enormous. All right, and again, space is so large, that's why we can't travel very far in space at all. The universe actually includes everything that we know in existence, so galaxies, stars, planets, moons. It's composed of empty space, energy, matter. We also call it dark matter. So we're trying to learn more about this dark matter as time goes on. The universe has begun with an explosion, right, which we call a Big Bang. So everything's all in one spot, explosion, and boom. Then it actually spreads out to where it is today, and then things start forming. And the universe is still spreading out since the Big Bang today. And the Big Bang, we believe, is around 13.9 billion years ago. That's when it happened. So a long time ago. The Earth actually formed a little bit after that. We'll talk about that. But the Earth in our solar system is 4.6 billion years ago. Okay, star is a large ball of gas held together by gravity. So again, gravity is the thing that holds everything together in space. It produces large amounts of energy by the process of nuclear fusion. Okay, and that's what provides our Earth this energy, right? We get the energy from our star, the sun. Okay, it occurs at high temperature, high pressure conditions in the star's interior. Okay, and we're talking about thousands to even millions of degrees Fahrenheit or even Celsius. Okay, so we're talking very high temperatures. Energy is released mostly in the form of visible light and UV rays towards the Earth. There are some other energies also, but a lot of that is shielded out by our atmosphere, thankfully. Otherwise, we could have some problems here on Earth. Nuclear fusion. This is what it is in a nutshell. So hydrogen, 2 hydrogen atoms, smash together, form helium, because that's a bigger atom, plus energy. Okay, and that's what forms our energy from the sun. So that's what we call fusion. All right, so the types of stars. Main sequence star, our sun is a main sequence star. It is a medium-sized star, 109 times the size of the Earth. That's how big the sun is. So you can fit 109 Earths across the sun. And most of the stars are this type. Okay, and this is actually a picture of the sun filtered out. These are what's called sunspots. So sometimes the sun actually gives off these what's called solar flares, and you end up getting dark areas on the sun. And we may believe that actually has possibility of changes of climate. So that's one thing. The picture on the right, that's an eclipse. You guys might have seen one in your lifetime. Okay, we did have one pretty recently, and when this video was made, but they're really neat if you get to observe them. Okay, giant stars, they're around 10 times the diameter of the sun, brighter than the sun, because the bigger the star is, the brighter it's going to be. However, a red giant, and this is the sun as a red giant, okay, yes, it is going to change into one of these, because remember, hydrogen's changing into helium, so it's a bigger atom. So eventually it will grow into one of these. The temperature will lower though. Okay, so it actually gives off less temperature, less energy as it becomes this type of star. Supergiant stars, these are the bigger main sequence stars that change into these. They're 100 to 1,000 times the diameter of the sun, the brightest stars in the universe. Enormous. And then a star basically blows up in an event called a nova or supernova. And what is left is the center of the star, or the core of the star, which is super hot. Okay, but it's much smaller. Okay, so these are white dwarfs. Not all are white. They kind of vary a little bit in color, but around the size of the Earth, hot on the surface, dim compared to other stars, because remember, the smaller the star is, the less bright it's going to be, and that's what we notice. This is a star that's dying off, and eventually will become what's called a black dwarf, a brown dwarf, or if it's a big enough one, it will become a black hole. This chart is called the Luminosity and Temperature star chart, and this will be used in Earth science when you take it next year. But basically it shows luminosity, which is brightness, okay, and the temperature. The hotter stars are going to be blue colored, followed by white, then yellow, and then finally red are the coolest stars. There are other colors in between that they don't show on this particular chart, but in general, that's the general trend of it. So blue are the hottest, red are the coolest, and then yellow and white are in between. Also, the main sequence make up the majority of stars. Then we have red giants, supergiants up here, which are higher luminosity, and then white dwarfs are down here with the lower luminosity. That's why they're a fraction of this. And the luminosity of 1, you notice, is the sun. So the sun is the comparison here. So any one that has a number higher than 1 is brighter than the sun. Any one that's lower than 1 is less bright than the sun. Okay, next we have planets. Okay, so planets are large spherical objects that independently orbit the sun. So these include, you guys know them from elementary school, I'm sure, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, which are the 8 planets that we know are part of our solar system. Then they made another category called dwarf planets, which Pluto is one of them. There are actually 3 or 4 more dwarf planets beyond Pluto now. So they could change this planetary model. Who knows in the future? But that's what we see. The way to remember this order, my very educated mother just served us 9 pizzas, right, to get the order of the planets in correct order. The sun is our closest star. That's responsible for the energy and necessary for life on Earth. If we didn't have it, we wouldn't have life on Earth. Okay, and here's the solar system. So you can see the size comparison. Okay, Mercury is very small, and so is Mars and Pluto. Venus and Earth are almost the same size, but you can see they're very small compared to Jupiter, Saturn, Uranus, and Neptune. Jupiter and Saturn are the biggest in our solar system. Jupiter, we believe, almost became another star in our solar system. It might be the biggest that a planet can be. These are called the gas giants, though. Jupiter, Saturn, Uranus, Neptune. Basically, they're made of gas mostly. They do get compressed into solids in the center eventually. It's usually solid ice. But basically, those are the biggest planets in our solar system. And then the ones in the beginning, Mercury, Venus, Earth, Mars, are called terrestrial planets. And those are mostly rocky, solid planets. Okay, and Jupiter, Saturn, Uranus, Neptune are called Jovian planets, which are gas giants. And then Pluto kind of doesn't fit the mold of the Jovian planets. And that's one of the reasons why it got removed from the planetary model. There is a planet rap. I'll put the link in the description below so you guys can actually hear it. It's actually really fun. And lastly, I want to get to the smaller objects in the solar system, which include moons. Okay, moons are solid objects that orbit a planet or even an asteroid in some cases, so there are weird instances of that happening. We also have asteroids, which are large, irregular shaped objects that orbit the sun independently. We have an asteroid belt between Mars and Jupiter. Again, why is that there? It may be a failed planet. May also have been a planet that got hit by something and then broke apart. So there's a lot of things that might have happened there, but we're not sure 100%. Comets also, which are masses of ice and rock that orbit the sun in large orbits. These orbits can take hundreds of years, over 100 years in some cases. And basically what it is, it's the ice melting coming off the back, and that's what makes its tail. I like to think of comets as dirty snowballs. That's a good way to describe them. So you can see the one down here. So this is the ice coming off the back and dust and all the material as it melts, as it's approaching the sun. The tail will always face away from the sun. These are asteroids, just to show you those. They can be irregular shaped, they don't have to be spherical. And then finally a moon, this is our moon. And we'll be talking more about the moon later in the chapter. And that's pretty much it. So I hope you guys enjoyed, and keep on studying.